If you put Ton 618 exactly where our sun is, it could swallow the entire solar system, and it would still have enough room to fit almost 40 more solar systems inside. But the real paradox isn't its size, it's the timing. We're seeing Ton 618 as it was when the universe was only about 3 billion years old. And according to most growth models, it simply shouldn't have had enough time to become that massive. So the question is, who fed this monster? Or worse, have we misunderstood the rules of the universe? Stay until the end of this video because you're going to see the two most plausible ways Ton 618 could exist, and both are terrifying, in two completely different ways. Today, we're going to follow the trail. How can something black shine like a cosmic lighthouse? How big is Ton 618, really? And most importantly, why does it slam straight into the Eddington limit? What is the so-called natural speed limit for how fast black holes are supposed to grow? Because if Ton 618 is real, then either the universe once had a shortcut, or we're missing a massive piece of physics. In 1957, during a sky survey in Mexico, astronomers noticed a faint pale blue dot. It looked like a distant star. Quiet, small, unremarkable. They logged it in a catalog. Ton 618. Just a tiny mark on a photographic plate. But the more they looked, the more that the dot started to break the rules. It was far too bright for a normal star at that distance, and if the distance hinted by its spectrum was correct, then that brightness was basically impossible for a star. It took years, spectroscopy, distance measurements, follow-up observations, before the truth became clear. This wasn't a star. This was the active core of a galaxy unimaginably far away, a quasar. And here's the paradox. One of the brightest things in the universe is powered by one of the darkest things in the universe, a black hole that's feeding. Quasar is short for quasi-stellar. It looks like a star, but it isn't one. Because a black hole itself doesn't shine. It swallows light. So where does a quasar's light come from? From the chaos just outside the black hole. Gas and dust don't fall straight in. Gravity bends their paths, twists them into spirals, and they form an accretion disk. The closer that material gets, the faster it moves, approaching the speed of light, and that's when it starts to pay the price. Collisions, friction, compression, torn apart in a cosmic grinder, temperatures surge from hundreds of thousands to millions of degrees, and that disk becomes the light source. It radiates across the spectrum: radio, visible light, ultraviolet, and X-rays. So a feeding black hole isn't dark at all. It's burning, not from inside the black hole, but from everything falling into it, right before it disappears. And once you understand that machine, the next number is going to sound unreal. Ton 618 is a quasar in the extreme category. At its peak, it could shine with the power of hundreds of trillions of suns. Imagine standing at the edge of a galaxy, above you hundreds of billions of stars, but at the center, one single point outshines everything. Like the entire galaxy is just a backdrop for it, not because it's a bigger star, but because it's a gravity engine, turning in falling matter into radiation with an efficiency that no star can compete with. And here's the key. That brightness is only the surface signal. The truly terrifying part is the invisible core behind it. At the center of Ton 618 is a black hole with a mass of about 66 billion times the mass of the Sun. To put that in perspective, Sagittarius A star, the black hole at the center of the Milky Way, is about 4 million solar masses. M87 star, the one the Event Horizon Telescope famously imaged, is about 6.5 billion solar masses. Ton 618 is 66 billion. That's not just bigger, that's a different tier of reality. Now let's talk about the event horizon, the point of no return. For Ton 618, that boundary balloons to the scale of an entire planetary system. If you placed it where our sun is, it could contain the solar system nearly 40 times over. And this is the detail that makes it feel unreal. Light, the fastest thing in the universe, would take about 11 days to travel from one side of its event horizon to the other. But size isn't the hardest part to accept. The hardest part is that Ton 618 became this massive when the universe was still young. And that's where the real question begins. How did it grow? Ton 618 is so far away that we never see its present. We only see its past. The light we receive today left Ton 618 when the universe was only around 3 billion years old. That means we're looking into an era when the universe was denser, galaxies were colliding more violently, and central black holes were feeding at extreme rates. And the strangest part is this. Whether ton 6, black holes grow by accreting matter, but the harder they feed, the hotter and brighter the disk becomes, and that radiation creates pressure, pushing incoming gas away. That's the Eddington limit, a built-in self-braking mechanism. Feed faster implies shine brighter. Shine brighter implies blow your own fuel away. And eventually the system chokes itself. So how did ton 618 reach 66 billion solar masses? In just a few billion years, it feels like the entire growth process was fast-forwarded, and this leads to the two most plausible explanations. Option 1. It started with a gigantic seed. In the early universe, a massive primordial gas cloud could collapse directly, forming a black hole seed that's already enormous. It doesn't begin small and slowly climb. It begins at a starting line. That should normally take an impossibly long time to reach. Option 2. It fed beyond the Eddington limit. In the early universe, gas was thicker, inflow was stronger. A black hole could go through phases of super-Eddington accretion, growing faster than the standard model allows. Add in constant galaxy mergers and black hole mergers, and the mass can jump in steps. And now you see why ton 618 is so unsettling. It forces us to choose between two universes, one where the initial seeds were already gigantic, or one where the Eddington limit can be broken, at least for long enough to build a monster. But ton 618 doesn't stop there. When it's active as a quasar, it does something even more brutal to its own galaxy. Ton 618 isn't just a record holder. In quasar mode, it becomes extreme feedback, a mechanism strong enough to rewrite the fate of the host galaxy. When a quasar turns on, its radiation and outflows heat the surrounding gas, and hot gas doesn't collapse easily to form new stars. In some cases, those outflows can even push gas out of the galaxy entirely, removing the fuel supply for the future. This is often described as a quasar quenching its galaxy. The galaxy doesn't vanish, but it changes state from a star factory into an older system with little cold gas, and almost no new stars are forming. So once you see that ton 618 both challenge the growth timeline and can shape an entire galaxy, the next question becomes, is it the biggest black hole we've ever found? There are candidates that might be even larger, like Phoenix A, with some estimates around 100 billion solar masses. But at these extremes, measurement uncertainty grows dramatically. And that's the real point. The question isn't who's the biggest. The real question is, how did ton 618 grow so fast, so early? In a young universe? That's why it remains a stress test for our models of black hole formation and growth. Ton 618 is like a message in a bottle drifting across a cosmic ocean. Its light traveled more than 10 billion years to reach our eyes, carrying a record of a younger universe, denser, wilder, more violent. And the strangest part is this: we will never know its present. We only hear its past, like an echo. But that echo reminds us of something important. The universe can build things beyond imagination. And sometimes the problem isn't that the laws are broken, it's that we still don't fully understand the game. If you want a follow-up video about how quasars can quench galaxies, or a deeper dive into the two growth paths that can feed a cosmic monster, comment ton below. Thanks for watching all the way to the end, and I'll see you in the next one.